our next speaker comes to us from Singapore. He's owner of Advent 2 Labs Consultation, the official FlexSim distributor in this region since 2013. Over the years, he has provided consulting services to numerous industries, helping them optimize operations with FlexSim. He's also a lecturer at the Singapore Institute of Technology and the author of several papers presented at international conferences such as the Winter Simulation Conference and AsiaSim. Today, he will present development of two-player training tool with VR. Please welcome to stage David Chan from Singapore.
Good afternoon, everyone. My name is David. I come from Singapore. Yep. Thanks for this opportunity that I'm able to be here to share about what we are doing. Though we are from a very far away land, but hope that we can still connect somehow, some way, all right? Okay, I'm going to have this presentation. The topic will be in the collaboration of two players VR training system using MQTT. But before I go into that, maybe I just would like to, in the sense that introduce my company and myself. We are the distributor for FlexSims since 2013, so it's almost about 20 years. Our company basically started as a company that deal with how can we improve operation. My background is in automation. Subsequently, even when I was teaching in the university, I would teach automation subject, PLC, we are talking about industrial engineering, anything under production, I'm teaching, all right? So my passion is that I would like to see how can I improve the operation. By moving just maybe waste paper basket from one point to another point, as long as I'm able to reduce the walking distance, that is an improvement, isn't it? Yeah? So therefore, I would like to see how company can improve in their process. And when I take up this distributorship of FlexSim, we are doing project to help company to improve their operation. Whether using the lean concept, using automation, using whatever means. As long as I can see an improvement in their process, that is what I would like to see. Yeah? So that is my passion all along. And when I started with FlexSim, a lot of people ask me this question, David, what do you do on Sunday? My answer to them is, play FlexSim. It's so fun. It's just like a computer game. And besides playing FlexSim as a computer game, I link it with the PLC as when it started, all right? So what I have over is a conveyor that transporting the seat and with their sensor that link with the model. And I think most likely I'm the first one who tried out this PLC emulation when it started in 2017, somewhere there, yeah? So, yeah, that is so fun with FlexSim, isn't it? All right, you can do anything in the world under the sun with FlexSim, right? Okay, today my agenda is that the thing that now I'm playing with is a VR training tool, all right? So what is VR training tool? The development of VR training tool using FlexSim. And the topic that we are using today in this particular training tool is a term called MQTT. And how is this being able to develop into a collaborative VR training tool? And some of the so-called latency about MQTT, because a lot of people are concerned, do we get the real-time communication kind of stuff, all right? So how MQTT works for this case, and lastly, I will just give my conclusion. All right, so the synopsis for today is that the use of MQTT has removed the limitation of one participant versus the one VR device, all right, allowed in the same environment. What it means is that we always have an issue that to say that I have a computer, I have a VR gear, I'm the only one who can play with that. No other people, all right? So therefore, if I want to have a more participative kind of VR game where other people can come into the picture, how am I going to do that? So there is a limitation, and today I would like to share with you how we did to remove this limitation that we can have a collaborative training tool, all right? So that is what we would like to do. And we know that VR training tool has been very popular nowadays. It has been used in many, many areas, all right? besides doing, the advantage of having the VR training tool is such that it allows people to have the training offline. So you do not have to be on the site, you do not have to be next to the machine, you can do it anywhere you want to, all right, even through remote or whatever way. So you can do the training with that. And you can also try out with the different scenario, because you just have to load the different scenario and you can work differently, all right? In fact, one of my dreams was to apply VR training into healthcare. Imagine there is somebody with a mental problem that comes in. So I'm able to look at through my VR goggle, okay, this guy is going to be very aggressive. So what am I going to do now? So there might be some so-called option for me to pop up, then I select that. Then in the sense that you can see how the reaction of the fella, all right, and respond to you. So that kind of things we can actually introduce into the VR with the different scenario. And training now is being done in a safe environment without endangering the new user, all right? And most important thing, at the end of the day, you have a measurable outcome. You can compare, all right? You can see what level are you at each or end of the game, yeah? So that's something that is very interesting using the VR. This is a picture I took when I was on the way from Singapore to Istanbul. That is in the business lounge. So this guy is on this machine with a VR goggle. I think what he's looking at actually is looking through the air balloon, all right, in the Istanbul area. So he was on that flying, yeah. So VR have been used in many areas, all right, including game as well. Now, FlexSim has developed VR roughly in 2017. Actually, you are seeing a picture of Bill, all right? He is the first guy now with the Oculus Rift on him. So even though FlexSim is a discrete event simulation platform designed to analyze operation effectiveness, but with the VR that hook onto the FlexSim, now you can actually use the VR to have a close encounter to the environment. And now you can actually validate the environment through your VR lens, all right? So it makes the whole a lot more to understand is instead of a 2D environment from a screen, but now you are walking through it with the VR goggle, yeah? And with the touch sensor, you can reprogram it so that you can interact with the model as well. So FlexSim team, they have developed this game, I'm not too sure whether you know, called the Zombie Attack. All right, it's in the high school, so they have a competition where the children actually playing with that. I think it's a very fun game, all right? If you have not tried, download it and test it out, it's fun. All right, as I mentioned, I like to play. I like to play with FlexSim, all right? So one of the earlier so-called project, my personal project is to develop a beer game on FlexSim platform, all right? I'm not too sure everybody know about beer game. It's from MIT. It's talking about supply chain, all right? So basically in this beer game, there are so-called 4 silos where you have the supplier, you have the warehouse, you have the manufacturer, you have the retailer. So we are trying to see what is the bullwhip effect in the beer game itself. When I developed it on the FlexSim platform, it's very fun because it's a 3D. But however, one of the regrets that I have in this game is that I can only have one player playing one role. All right, one player playing one role. So therefore, in the sense that I cannot have a team participation, all right, in this particular game. I have to select, I'm the manufacturer now. So I'm playing the manufacturer role. How can I respond in the sense to the random demand? Yeah, so that is what I can. How I wish I can actually have a few people playing at the same time, all right, so that they will play different role, all right, so we can actually collaborative to play about this game, which is much more fun in that sense. Actually, it's also in the sense that you learn much more effectively about the bullwhip effect, yeah? So that is one of my regret, even though in the sense that it is presented in a VR manner, instead of the 2D kind of animation. If you download, you go to the MIT website, they do have a beer game, so-called 2D game over there. But the 3D is much more nicer. Even it is much more nicer when it is in the VR, all right, in the VR. So that is the limitation in our development. So only one player can play with one VR goggle at the same at one time, all right? So that is my regret with the development of this game. And therefore, there come a stage, actually this project was started last year with one of my students from the Singapore Institute of Technology. He also attached to my company. So I was just discussing with him, then he was proposing why not you use MQTT. So what is MQTT? MQTT is a message queuing telemetry transport system. All right, so basically what happened in this, it will operate on a TCP where it utilizes a publish and subscribe communication model, and it is hosted over a broker. So information is published, all right? Information is published over here to the MQTT so-called protocol, and it was sent to the different devices that subscribe to the MQTT. So we are trying to see if we can share the information from different devices using this kind of communication, all right, with this kind of protocol, all right? And this MQTT, one of the advantages is that it requires very minimum resource and make it become very lightweight, all right, for you to share information across different simulation platforms. We heard about this term called distributed simulation. FlexSim, we used to have such a so-called project on that. It is very, very heavy, all right, because you need to synchronize the timing between the different instances on the same model itself on the different device. So the MQTT has the advantage of this asynchronous. That means that basically it does not really require a real-time synchronization. Important is that it does not require a real-time synchronization. So therefore, if you allow a few second kind of delay, if it is all right with you, this is the right tool to be used. All right, this is the right tool to be used. And so this is the architecture that we have. So we have actually 4 different computers, all right, loaded with the same model. All right, 4 computers loaded with the same model. They are connected to the Maria database. Why we use Maria database? Because it is free. All right? So we will have all the game score recorded over there and read from there. And all these devices, basically, they will synchronize through the MQTT. They publish the information, they subscribe the information from the MQTT, and hence, therefore, they are able to share the information for the 4 players at the same time. Right? When I say at the same time, it's not real time, but with certain delay. But if you're able to allow that such delay, it is totally fine. Yeah. So therefore, actually, we're able to establish this game, all right, for same model in 4 different computers with 4 different players playing at the same time. Yeah. And what we did in this particular game is that we actually created a model of a fan, all right? I'm not too sure whether you have seen this product before. In Singapore, it's very, very hot, so everybody almost carrying one of these, all right? So this is a mini fan, all right, mini fan. So the guy actually is supposed to assemble this thing, all right? And 4 players, 2 in each team. One guy is doing the assembly, and then the other guy is testing, doing the QA job, all right? So the objective is to assemble this fan that consists of a base, a blade, and cover by one player, and then the other guy will become the QA. And in terms of the synchronization, all right, MQTT required to subscribe to different topics. All right, so therefore you need to actually define what are the topics that you have. Over here, maybe the score player, when the player is around, player not around, player is ready, player is unready, what is the difficulty level. So all this information you need to talk to one another before the game start, or need to synchronize before the game start. So therefore, in the sense that MQTT allow you with this kind of topic, you can actually synchronize with the different player to work around. And one of the things also, we actually use a scoreboard where the information is stored into the Maria database so that we can track the so-called information. At the end of it, we can also have a competition between the 2 groups and see who is doing better. So one thing I would just want to say that actually, whether it is a training tool or whether it is a game, they actually the same thing, all right? They are for fun, or they are also for serious thing, for learning as well, all right? So basically, this allows us to actually to have a score. We're able to actually do a ranking as well. So if there are few teams, actually we can have a scoreboard, then who is the highest score kind of things, yeah? So we can actually have this display of the ranking. Now, At the end of the day, we are not happy with what we are doing, so we enhance this with kind of collision avoidance or collision logic. So if you are not able to assemble the thing according to that right direction, you are colliding, then actually the whole fan will jump. The so-called the blade will go back to its original location. You have to redo it again. Yeah? And we also play with the different so-called difficulty level between the fan and also the way they assemble. So we increase the difficulty level and also the randomness, where is the location of the fan. So therefore, in the sense that they create different kind of scenario inside the game so that the people will not always have the same scenario. All right, so we increase the so-called difficulty level. And if the fella, the QA check the fan, if the fan does not pass, then they will actually have suffer some penalty from that, so we'll minus from the score. All right? So these are something that we actually need to be in the game because these are some of the components to motivate the user, to also in the sense that causing the user to feel, I can do it one more time, all right? That kind of feeling, yeah? So that's important in the game design. Now, at the end of the day, everyone is very concerned about the latency because if this thing in the sense that is slow, then in the sense of how this 2-person that is in the team, or maybe this 4-person in these two groups able to synchronize with one another. And we have tested it out, all right? We have tested it out. In fact, the maximum latency is only 0.011 second, all right? 0.011 second. How fast is 0.011 second? Over, right? So it's very fast. So in the sense that it actually does not affect the performance of the game. So we find that in the sense that the performance is fine, right? Even though we are using MQTT, it's not supposed to be the best, it's not really real time, but it's fine, all right? Even with a minimum of 0.001, all right? So that is fine for us. And so we'll say that this game is okay, but in terms of enhancement in the future, we actually would like the game in the sense that the people who are able to stand at the fixed position, because you know that when you are playing with the VR, always teleporting. So suddenly if you do not press it, suddenly you press it wrongly with the touch sensor, you might be teleported to somewhere else, all right? So these are the things that we are concerned with. And also the object placement control. How do we desynchronize the agent so-called prevention? So that is to say that if an MQTT message is not delivered, all right, we need to keep the old message, all right? We need to keep the old message. If not, the whole thing will be desynchronized, all right? Because the timing is different. So we need to keep the old message so that we can refresh the whole thing with the latest information, yeah? So these are the things that we need to actually further enhance into the system. Other than that, we also want to put into the game state control. So apart from the optimization, the game state control prevents the user from interacting with the object that does not belong to them. That means if I'm the quality control, I do not be busybody go and help the assembly, all right? So you cannot do such thing because that is not within your assigned role, all right? So you cannot do that, so we can control that. And we also can have multiple instant database updating to prevent the conflict, all right, where multiplayer are doing the same thing. That means the next team come over to sabotage you, all right? So we do not allow that to happen. Yeah, we do not want that thing to happen. Yeah. So these are something that we actually would like to put into the game itself to enhance the entire thing. The end. The thing is that this is not really an industrial application, all right? But we are actually using this project with the student to prove our concept, whether we can actually have more than one player working on the same model through a certain so-called protocol or platform. Yeah, so this is a testing of the concept. So at the end of the day, we find that this concept, it does work, all right? So therefore, in the sense that we can make use of this approach using MQTT to develop some collaborative training or learning system where you have a team to work together, all right? Nowadays, we will actually would like to have more people to participate into the whole learning process because the interaction of the people are important, all right? Not only by themselves, but we need to see how they are being interacting one another. Lastly, FlexSim is such an open system simulation platform. They're so fun, all right? That allows you to work with VR, AR, IoT, AI, ML, all right, to provide the support with the I4.0 and I5.0 as well. So with this, I would say that FlexSim is something that's so fun. Please enjoy them. All right, thank you so much.
Thank you, David. Thank you for your inspiring words. Any question from the audience to David?
Too fast?
Yeah, there is one.
Young people like game.
First of all, good day. We are welcome you here in Krakow, Poland. And my question about technical stuff, because it was very interesting to learn something new about FlexSim, and it's about network. It was tested on the local network or on the dispersed network, like different providers, different computers with different specifications. Because as I understand, FlexSim used like a local machine, and users navigated through database to exchange data. And if someone computer will lacking of computing power, will it influence the latency?
All right, good questions. Lucky my game doesn't require a lot of resources, so it works. Yeah, so I think you know that FlexSim, you use a lot of resources, especially your model getting more bigger and require more memory. Hence, therefore, in the sense that I think when you are developing training tool or VR stuff, all right, try to reduce that kind of polygons or the heavy resource so-called utilization, all right? And for me, our 4 machine basically are using my intra network within the company, wireless. It is not wired network, wireless network. Thus far, it works fine, all right? So I think, yeah, there could be certain limitation, but I think we need to look at how can we reduce that kind of graphic dependence. And I think for game-wise, your so-called data required, or maybe your objective have to be clear when you design the game, so that you do not have to add in too much other information as well. Yeah, you need to streamline that information. Do I answer your questions? Thank you.
Okay, someone else maybe want to ask about training in VR? Okay, so let's thank David once again with applause.
Thank you.